We are now ready to create a function that will add the nodes to our list. So I have the start of a program here. Here's my main function. I'm going to create a pointer variable called head that will contain the address to the first element on the list. And then I'm going to create a variable num to hold in the numbers that the user enters. And while cin, meaning while cin is in a valid state, I'm going to prompt for an integer, read it in, and if cin is still in a valid state, I'm going to go ahead and call the function to add the integer to the list. The reason I'm doing it this way, and there are multiple ways of doing this, but when my user enters something other than an integer, cin will go into a fail state, which will stop the loop, and I won't add it to the list if cin is in a fail state. So now let's go ahead and call the function. So I'm going to call add to list, and I'm going to pass it head and then the number that we want to add. A variable called head, and it is pointing to nothing, so it has null in it right now. So our list is empty. And when I pass that to the add to node or add to list function, this variable down here is another separate variable called head. Okay, so we have a variable head in our add to list function, and then we have a variable head in our main function. We're not passing by reference, so if we update head in the add to list function, it's not going to update head in the main function. So that's why we're going to return the address of head at the end of the add to list function, and then we'll update head in the main function. So I'm going to add some syntax here on line 21 to update head to the address that is returned. Okay, there's another way of doing this with double pointers, but we haven't covered that yet, so I'm not going to do it that way. To draw a picture of what is going to happen, the first time that I call the function, head will be null. And so I'm going to go ahead and I'm going to create my node out in memory, assign it the value that the user entered, for example 3. I'm going to update its next pointer to null, and then I'm going to set head to the address of that node. And then I'm going to return head, so that will update the head in main. So now head and main will be pointing to that memory location where that node is. The next time I add a node, I will test head, and head will not be null because it will be pointing to this element with the integer 3 in it. I'm going to traverse the list to find the end of the list. And so how I'm going to do that is I'm going to start at head, and then I'm going to look at the node's next variable. And if next is null, I know that's where I'm going to add the node. So I will go out into memory. I'm going to create my node, assign it the value that the user entered, 5 for example, set this to null, and then this will now be pointing to that. Okay, and then the third time when I call the function, I'll pass head. Head will not be null, so I'm going to loop through the list. I'm going to get the next node, and if next is not null, I'm going to get that node. And if that node's next is not null, then I'll get the next node. I'll keep doing that until I find a node where the next is null, and then I know that's at the end of the list. And I'm ready to add num to the end of the list. So I'm going to need to create a pointer variable to hold the address to the new node. So let's go ahead and create a pointer variable, and I'll call that new node. And then I'm going to allocate new node. And I'm going to set new nodes num to num, the number that the user has entered. And then I'm going to set new node next to null pointer. Now I need to figure out where it is on the list. So if the head is null, so if the head equals null, which I can say if there isn't a head, then I'm going to add it as the head. So I'll say head is assigned new node. And then at the end of my function, I'm going to return head. And when I return head, it will update the head in main to be pointing to that first node on the list. Let's run through this code and draw it out for the first node. So I prompt the user, they enter the number 3. I pass head and 3 to the add to list function. A new node is created with the number 3. I set the next to null pointer. And then if there isn't a head, which there isn't, that's true, I'm going to set head to new node. So now head is going to be pointing to this new node. And then I'm going to go ahead and return head at the end of the function. So now this head will be pointing to this node because I'm going to assign it at that location. But what happens when there are elements in the list? We will need to loop until we find a node with a next equal to null, and then we know that's the end of the list, and that's where we will be adding the new node. So to loop through the list, I'm going to have to save each node into a variable and then check its next member. I'm going to create a variable pointer called current node. If there isn't a head, I'm going to go ahead and add that there. Else, I'm going to set current node to the head, and I'm going to start looping, looking for a node that does not have a next value. So while current node has a next, so there's something in that field, right? So that will be true. While this has something in the field, I'm going to loop. And I'm going to just set current node. I'm going to set current node to current node next. And that will loop through the list until I find the end of the list. Once I find a node that has an empty next, I know that's where I'm going to put the new node. So the loop will stop looping, and then I'll say current node next is assigned new node. And that will append the new node to the end of the list. When the user enters the number 5, I'll create my new node, add 5, set next to null, and then I'm going to loop through the list. So I'm just going to set current node to head, so it will be pointing right there, and then I'm going to check, does current node next have a value? No, it's null. So I know that's the node that I'm going to be appending my new node to. So then I'm going to set current node next to new node. So then current nodes next will now be pointing to new node.